Hello, students. Had a question come through about question number 15 in 8.3. And so if you take a look at this one, let's do that. It's talking about a function. Now, this type of function is often called a rational function because it's a ratio, if you can picture that. But when we're trying to solve those, we would solve those in the same way that we would do with any of the others. So if we just kind of white out that piece here, maybe slide this over just a bit. There we go. And let's take a look. Let's see what we can do. So like for part A, if we want to find, let's read the question carefully. Make sure, consider the function. So here's our function and find all possible inputs. Aha. So I need inputs that give the following outputs. So again, this is an output. So the output goes on the outside. So what I have is I have 2x minus 1 over 2x plus 1. That is supposed to equal the number 2. And so then if I want to, this is something I can do going all the way back to when we did this in chapter 6, where I could multiply both sides by the same quantity. And over here on the left-hand side, a 2x plus 1 on top and a 2x plus 1 on the bottom go away. On the right-hand side, it doesn't go away, but it gives me this nice little 2x minus 1 equals, and then don't forget to distribute, right? So 4x plus 2. And now you can just get all the x's on one side using kind of your typical approach. Get rid of two x's on both sides. This feels like a pan balance, doesn't it? Right? I'm taking 2 off of both sides and they stay equal. And then we put an equal sign here and we have 6x plus 2 supposed to equal -1. So again, now just subtract the 3 to both sides, divide by 6, and we should be there. Okay, so that's the idea there. And then you go back and check yourself as well, right? You're gonna make sure you do that. Let's see. So I want an output of 2. Let's see here. So this, if I bring this to the other side, it'd be like -3 equals 6x. So -3 over 6 equals x. But let's check. If I put that's -1/2, right? So if I go back to my original function and I say, let's plug in a -1/2, let's see what happens. I get 2 times -1/2 minus 1. I get that divided by 2 times -1/2 plus 1. If I do that, and let's see here. 2. Oh, take a look over here. I also cut myself a little bit because I was like, wait a minute, something's going on. So 4x minus 2x should have been 2x. Some of you probably saw that. There's a 2. So this should be a -3 over 2. And so I'll just make that little change there, -3 over 2. And let's check ourselves. So 2 times -3 over 2 is -3 minus 1. 2 times -3 halves again is -3, but this is a plus 1. So this gives me a -4 on top, a -2 on the bottom. And that means the output is 2. So it checks out. So what is the input for part A? The input would be x equals -3 halves. Okay. What changes for all the rest? Nothing. All you're doing is you're putting in whatever value they give you and you go check it. So if I want to do 0, then I would put a 0 right here. And of course, when I multiply anything by 0, this whole side becomes 0. And then you can go through and just solve, try to get x by itself right there. So that's one way to do it. Yeah, I think it's probably the easiest way. I can't think of another way really where you'd I guess you could try guessing and checking if you were trying to do that, but that seems a little weird. Um you won't be able to use this on the test, but you're at home doing it. So if you were to take, let me clear everything off of here, but it was 2x minus 1, 2x plus 1. So if I came in and went to Desmos and did a graphing calculator on that, and I just said, okay, let's do f of x equals 2x minus 1 divided by, oops, I need the whole thing. 2x minus 1 over 2x plus 1, then this is the graph that I see on the screen, if you can see that. And I want the output from this would be the y value. If I want the y value to be 0, then I can find it here. If I want the y value to be 2, then I need to find when the output value, that'll be the rightmost coordinate, is 2. And so I'd come up here and I'd say, okay, it looks like it's right around negative, there it is, negative 1.5, which is the negative 3/2 we found a moment ago. So yeah, you kind of, I mean, you could check your work here visually. If you wanted to kind of say, well, wait, how else could I do it? Just say y equals 2, and then you can find where they intersect. That's a y value of 2 intersecting that function. So again, that's visual, but again, you won't have that on the exam because we won't have that ability, but everything else is ready to go. Okay. So hopefully that helps. Let me know if you have other questions. Off you go.